I don't think so. We are going to do binomial problems basic, they say. Suppose that the New England Colonials baseball team is equally likely to win a game as not to win the game. If 5 Colonial games are chosen at random, what is the probability that exactly 3 of those games are won by the Colonials? So what we're going to do is first of all figure out the combinations of ways that we can do this. We have 5 people, chosen 3 at a time. So we're going to figure out that number. Do you remember how to do that on your calculator? I got to look at the calculator.
10.
10. Yes, 10 is the answer. So, in order to do that, what did you do?
I went to math.
You went, first of all, you put in the 5, right?
Oh, yeah.
5 math. Then we cursored over to the probability on the top. And number 3 is your combination. See that? Okay, you hit number 3. And then this one, we're actually going to type a 3 because we want to do the combination of 3 things if we have 5. And when you hit equal, you get 10, right? Okay? We are going to multiply that then by the probability of each of those things, one that it does happen, one that it doesn't happen. So in this case, since it's an equally likely to win the game, they have a 50% probability, right? So I have 50% probability that they'll win the game and a 50% probability, this one's going to be to the second power because they did a total of 5 games. Now again, these 2 things should always add up to your 100%. Most of the time they give you the percentage, but here they just said it was equally likely, so we have a 50% chance of winning and a 50% chance of losing. And so that's what we're going to do, is we're going to take 10 times 0.5 to the third times 0.5 to the second. Win, lose. And we are rounding these off to 3 decimal places again.
0.313.
313, yep, 0.313. Okay, number 14, going to be the same kind of thing. TV executives is interested in the popularity of a particular cable TV show. She has been told that a whopping 68% of American households would be interested in tuning into a new network version of the show. If this is correct, what is the probability that all 6 of the households in her city, being monitored by the TV industry, would tune into the new show? Assume that the 6 households constitute a random sample of American households. So, first of all, for my combination, I would have a combination of what? How many total? How many households?
6.
6. And how many are going to monitor the TV industry? All 6 of them. So we have a combination of 6 out of 6. All 6 out of the 6 that we had to choose from. What do we get when we do that? 1. 100% of them are going to say yes. No. So we are then going to do that times our probability, 68%, and all 6 of them are going to do that. Then we're going to use the percent that are not going to. The percent that are not going to, if I take 1 minus 0.68, I get 0.32, and nobody's going to do that option because all 6 of them are doing the first option. So we're going to take 1 times 0.68 to the 6 times 0.32 to the 0. .099. Yep, that's what I got. So, 6 households, we want all 6 of them to say yes. 68% said yes, so 68 to the 6th power. 32% would be no, but we had nobody who chose that, so we had to the 0 power there. Now, let's see on number 15 then, if we can figure out our formula. So, it doesn't like me because I have that in my hand. Anita's a fast food chain specializing in hot dogs and garlic fries. Keeps track of the proportion of its customers who decide to eat in the restaurant as opposed to ordering food to go. So it can make decisions regarding the possible construction of an in-store play area. That seems like the same question, but that was the previous bunch. The attendance of the mascot Sammy at the franchise location, and so on. Anita's report that 52% of its customers ordered their food to go. If this proportion is correct, what is the probability that in a random sample of 4 customers at Anita's, exactly 3 order their food to go? So, first thing I'm going to do is figure out my combination. I'm going to do a combination of 4 things taken, 3 of them that are going to order their food to go, right? So, combination of 4 things, and we're taking 3 out of the 4.
4.
And we get a 4. We are then going to multiply by its probability. Those who are going to order their food to go were 52%. And how many out of the 4 we're going to do that? 3. My other percent that are not going to order their food to go would be 48%. And how many out of the 4 are going to do that?
3.
Nope.
Or
1. 3, we're going to order it to go. That only leaves 1 left that is not going to order it to go. So these 2 numbers here should add up to your 100%. These 2 numbers here should add up to the total number of people that you sampled.
.26 or 70.
0.270, yep. That's what you should come up with. Okay? And the last 3. These are the ones that we're going to show you a shortcut if you